What is up, math superstars? In this edition of Mr. Peterson Presents, we're going to talk about how to use replacement values when we have expressions with variables. And so to evaluate an algebraic expression, what we're going to do is we're going to replace the variable or the variables with known values. So the first step is we're going to replace it where we have to write out what we replaced. And then we're going to go ahead and use good old-fashioned order of operations. And so here we're given this example. It says evaluate x plus y minus 9 if x is equal to 15 and y is equal to 6. So what I'm going to do is I'm going to go ahead and just write out everything that I know. And then what I'm going to do is I'm going to replace x and y. And so x is 15, and then y is 6. And I'm going to go ahead and write in everything else that I know. And then it says evaluate using order of operations. So I have 15 plus 6 minus 9. I'm going to do 15 plus 6 first is 21 minus 9. Giving me 12. And so what I did was, it's just like order operations, except we have one extra step where we have to use the replacement values to rewrite and replace the variables that we have. And so, but some helpful hints: when substituting negative numbers, we're going to put parentheses around the replacement value. And so what this means is that if a is equal to negative 2, we need to figure out what the opposite of a is going to be, or negative a. So when I do that, I'm going to put negative, and then inside the parentheses, I'm just going to highlight what a is. A is negative 2. So you can see it looks kind of crazy. I have a negative and then a negative 2. I have negative on the outside and negative 2 on the inside. What this is really telling us is that I have negative 1 times negative 2. So I have a negative times a negative is going to be giving me a positive. So I can say that the opposite of a, or negative a, will become just positive 2. So you can see in the replacement values, I just put parentheses around it to make it easier. So what about this one? I have a squared. And so what I'm going to do is I'm going to fill in what a is. A is negative 2. And then I'm going to bring down the exponent. And so what this is telling me is that I have negative 2 times negative 2. So negative times negative is a positive. So that's going to leave me with positive 4. And so what about negative a squared? So I have negative, I have my parentheses, I have my squared, and then a is negative 2. And so we have a lot of different order operations here. I'm going to rewrite this negative as negative 1 to be able to help me a little better here. I'm going to add a multiplication sign. It's all there. We just have negative 2 squared here. So I'm going to do the negative 2 times the negative 2, giving me positive 4. But then I have that positive 4 times the negative 1. So if I rewrite that, so negative 1 times positive 4, it's going to give me negative 4. And so it seems a bit tricky, but the real key about this is to use the parentheses around the negative replacement values. And so let's try a couple examples here as we get moving and grooving here. We have number 1, we have 6m minus 3k. And so we're given some information. We're going to evaluate if k is equal to 2, m is equal to 7, and n is equal to 4. And so what I'm going to do first step is I'm going to rewrite this using the replacement values. And so I have m is 7, so I have 6 times 7 minus 3 times 2. And then I'm going to do some order of operations here. So I have 6 times 7 is 42. Minus 3 times 2. Then I have 42 minus 3 times 2 is 6. And 42 minus 6 is going to give me 36. And so you can see that my very first step is that I used the replacement values and I wrote it out before I did any order of operations. And then I did the order of operations one step at a time. So here we're given this one, we have mn over 2 here. And so let's go ahead and rewrite it with the replacement values. So m is 7, n is 4, and it's all over 2. So I'm going to do everything in the numerator first. So I have 7 times 4 is 28 over 2, and then 28 divided by 2 gives me 14. And so you can see here is that I showed that step of the replacement values, and then I did one step at a time using order of operations. So here we go. So we have m plus the absolute value. So we have absolute value bars, k minus 2m. Before we worry about anything, let's go ahead and use our replacement values here. So m is 7 plus the absolute value, k is 2 minus 2 times 7. And so the absolute value bars, we're going to do everything inside of that first. And so I have 2 minus 2 times 7, so I have multiplication. So I have 14 minus 2. I'm going to go ahead and rewrite everything out. And then I'm going to do 2 minus 14 is negative 12 plus 7. You can see I rewrote the absolute value bars here. Draw my arrow. The absolute value of negative 12 is positive 12. So I have 12 plus 7. And then 12 plus 7 or 7 plus 12 gives me a grand total of 19. And so you can see that I showed all of my steps, and the key is writing out the replacement values first and showing your work in a neat and orderly way, one step at a time. So for these next examples here, so we're changing up the variables, we're changing up what their values are. So we have A is negative 5, B is positive 3, and C is negative 4. So we have 6A minus 4B. So I have 6 times negative 5, and then minus 4 times positive 3. So I rewrote that. Now we're going to do some steps here. So I have 6 times negative 5 gives me negative 30, minus 4 times 3. Do multiplication next. 4 times 3 is 12. And I'm going to rewrite everything. Then I have negative 30 minus 12. And I know that's the same thing as negative 30 plus negative 12, giving me negative 42 as my answer here. And so you can see that I did my replacement values, and then I did order of operations. All right, so we have this problem. We have C plus A in parentheses in the numerator, and then we have negative B in the denominator. So our first step is that we're going to replace our variables with the given values for A, B, and C. So here we have C is going to be negative 4, plus A is going to be negative 5. I'm going to write my fraction bar, and then in the denominator is the opposite of B. So we have negative, and B is 3, so B is positive 3, now we have negative 3 in the denominator. So next step is we're going to use order of operations. So we're going to do everything in our numerator first. So we have negative 4 plus negative 5 will give me negative 9. And then my denominator is negative 3. And the last and final step to be done with this is we're going to go ahead and simplify this fraction. So we know that negative 9 divided by negative 3 is going to result in a positive 3, because we know that a negative divided by negative will give me a positive. And so after we replace the values and do order operations, we are left with positive 3. Number 6, we got a lot here going on, but guess what? We're going to do it one step at a time here. So I have 5 times negative 4, and then plus, in parentheses, I have a squared. So I have, what I'm going to do is I'm going to put negative 5 squared to help me out, plus 4b, so I have plus 4 times 3, And you can see here that, oops, that should be in blue. So you can see inside these blue parentheses, we got a lot going on there, but I kind of grouped it in a way that's going to help me out. And then I have subtracting 15. So let's go ahead and do everything inside the parentheses first. So I have negative 5 squared. Negative 5 times negative 5 is positive 25 plus 4 times 3. I'm going to put that in parentheses again. Negative 15 plus, and then what I'm going to do is I can probably do, no, let's rewrite everything. So I'm going to do it one step at a time to make sure I'm accurate. And then I have 25 plus 12 minus 15 plus, and I'm rewriting everything out. And then 25 plus 12 is 37 minus 15 plus, oh, I'm resisting that urge just to do that right now. But you can see I'm just working one step at a time. So that way it makes it super easy to check my work here. So I have negative 20 plus 37 minus 15. I'm running out of room, so I'm going to go ahead and use this little side right here. So negative 20 plus 30 plus 37 is going to give me 17 minus 15. And that's going to leave me with a grand total of 2. And so all of that work to just give me 2. But you can see here that I showed all my replacement values first. I made sure I was neat and clean with using the parentheses. Made sure it was all there to start, and then I worked one step at a time. This one took a lot of steps. Guess what? Some of these are going to take a lot of steps, but if you show the replacement values and you work one step at a time, even if you get stuck on something, maybe you did negative 5 squared gives you positive 10 for some reason, you can go back and find your mistake much easier than if you're just scribbling down a bunch of steps that you think are the right ones. In fact, you combine some steps and miss some things. So you really want to try to pay attention to every detail here for accuracy in using replacement values.